Hey everyone, welcome back to my channel, Math Made Simple. Today we are going to explore one of the most powerful concepts in maths, indices. Whether you are a student or just love math, this video is for you. So let's dive in. What are indices, students? Indices, simply you can say that it means is powers or exponents, right? Actually, indices is the plural form of index, right? And it means exponents, or you can say powers, right? For example, if we'll write 2 3 times, so how are you going to write down in the index form or in the exponent form? We will write this 2 how many times? 2 3 times. 1, 2 and 3. So here it's 2 to the power cube, right? So you can say that indices are a shortened way of writing repeated multiplication, right? The example is in front of you. So we in this video we will learn the laws of indices, the basic laws of indices, right? So the first law, and one thing is very important about indices, that indices only applies in multiplication and division. So the first law is that when the bases are same, right? These are the bases, right? When the bases are same, so what we will do, we will add their powers. Here in the above examples, this 2 is actually the base and this 3 is the power, right? So the 2 is base. 2 is called base, or you can say coefficient. In the first law says that when the bases are same, like here in this example, x times x, right? When the bases are same, their powers are going to be added. So here, the first x has a power 5, and the second x has a power 6, right? So how to write down the answer? It means you need to take x common, right? Because the bases are same here, and add the power. So 5 plus 6 gives you x to power 11, right? The second variation of the first law is the division. If I'll take the same example like x times, sorry, it's a division, okay? So if I'll take x divided by x, and here the power I can take 10 and 5, right? So I need to write down the answer. So though it's a division, so we will take x common, and instead of addition we'll do subtraction. 10 minus 5, so x to the power 5 is the answer. This is the first law. Let's do the next example. Like even the example is like a number form. 10 to the power 12, right? And divided by 10 to the power 4. The first two previous examples were about the variables. Now we have a numbers here, but the procedure is same. We will take 10 common because bases are same here, and then the powers or the exponent is subtract. Okay, so here 10, the first 10 to the power is 12, and the second 10 here it's 4. So though it's a negative sign, so we subtract them. So answer is 10. 10 to the power? Yes, 10 to the power. Come on, 12 minus 4 is 8. Okay, this is the first example. Now, second example. sorry, second law. So in the second law, we have the bases are different. Okay, the bases are different and the powers are same. So when the bases are different, for example, uh, a to the power m times b to the power m, right? Both the powers have same. So how you will solve these types of questions? What we will need to do, we will take m power common, right? So a times b, and we will take m common here. So if two different bases with the same powers are being multiplied or divided, so you can take power common, right? In the second variation, like in division, a to the power m divided by b to the power m. So how are you going to write down there? We can take one power common, right? This is the second law. Now, third law. Now, third law says that you're allowed to open power directly if terms are being multiplied and divided. For example, okay, a times b, right, and it has power m. So a times b to the whole bracket. Okay, this is a whole bracket. M is outside. M is outside means like m is an a as well and b as well, right? This m power is an a as well and b as well. So how are we going to open them? We can easily open a to the power m times b to the power m. The second variation is a over b and the power is m. So here m power is on a and b as well. So you can easily open the bracket a to the power m and b to the power also m. Okay, so question is here, you are not allowed to open the powers directly if the terms are being add or subtract. Add or subtract means instead of like multiplication, if the question is like a plus b the whole square, so you cannot open them like a to the power square and b to the power square. This is totally wrong in algebra, and you know that this actually is the first identity, right? Maybe you know about the first identity. This first identity, you can only open this with the help of the first identity. So how are you going to open this? A square plus b square plus 2ab. So it means that the indices only applies in multiplication. So now you understand that in indices, like in addition, maybe you people have made a mistake. You people make mistakes in the indices, sorry, in the identities, right? So whenever you have addition sign, you cannot open it like a square and b plus b square. This will be totally wrong. So in when we have power like outside the bracket, okay, so only we can open when we have a multiplication sign or we have a division operation here, okay, but not in addition and not in subtraction. So if subtraction means that it has a second identity. If I'm going to write down a minus b the whole square, this is the second identity. So you cannot open this a square minus b square like you have opened in the previous law, right? So be careful, students. Indices only applies in multiplication and division. Now we have a fourth law. In fourth law, we will learn that how we're going to solve power over power. For example, a to the power m, and then the bracket is there and again the power is outside, so power over power. So here what we how we have to solve this? So in power over power we always multiply the m times n, it gives you a mn, right? For example, If the variable is x and its power is 3, the whole power is 2. Okay, so x to the power 3 and the whole power is 2. So how are you going to solve this? So we just multiply 3 times 2. We will not add them, right? So only we will multiply. So answer is x to the power 6, right? Now, fifth law. In this video, we only revise or we only learn till 5 laws, right? And in the second video, we will learn the laws, like you can say that little bit advanced level, right? So these are the basic laws. The fifth law is the negative powers. So math people hate negative powers, you know. If a to the power, let's see the example, a to the power minus m here. So you need to convert this into positive. How? You know that every number, every variable has in the denominator side, like we have a 1 here, right? We can forcefully make this a into a fraction by putting 1 underneath, right? So how are you going to make this example positive? They're going to reciprocal, or you can just reverse them, right? So reverse how? 1 will take as a part of the numerator and a will go down. When a will change its position, like from numerator to denominator, it will automatically convert it into a positive, right? Let's do another example. Like if A over B and it has a power minus m. So when we reverse them, it will automatically become positive. So B will take the numerator position and A will go down as a denominator. And this m will come positive, right? So you can say that we reciprocal the bases, right? So the signs automatically change. The signs, the power signs has been changed. Let's do some few other examples. If 2 to the power minus 3, right? So how are we going to convert this into a positive? 1 over 2. So the power turned into positive. Next example. And it has a negative power of 3. So when we reverse the bases, like 2 over 3 is the question, we'll make it a 3 over 2, right? And the powers automatically will become positive, right? So how are you going to solve it? This is actually the index notation form, okay? So how are you going to solve then? The answer, the final answer, like 3 times and 2 3 times, right? So it gives you an answer 27 over 8. I hope students, you people learn the concept of basic indices laws. We'll meet in the next video. Bye bye.